Gentlemen, take your seats. This is the ASI Boardroom. Markets are currently blinded by the surface-level noise, but we're here to quantify the tectonic shifts towards superintelligence. I am Raphael. Today's briefing exposes the strategic architecture behind the future of AI engineering and the hidden maneuvers currently orchestrated outside the public eye. Let's get to the bottom line.
Here is the agenda for today's briefing. We'll cover the bluff, Pillar 1 on Software 3.0, Pillar 2 on verifiability, Pillar 3 on agentic swarms, and finally the ASI trajectory. We are treating all of this data as intercepted architectural blueprints of the new AI economy. Let's dive right in.
Okay, so here is the executive bottom line up front. Traditional human-written software, it's basically dead. We're witnessing a permanent transition right now. The future doesn't belong to explicit lines of code hand-typed by humans anymore. It belongs entirely to end-to-end neural networks and the autonomous agents that operate them. Look, if you're still building for the old paradigm, you are already obsolete.
Pillar I, Software 3.0 and the bitter lesson. To really grasp this shift, we need to analyze how computing is moving directly from historical models into the frontier of neural computation.
Our intelligence intercepts from key frontier architects break this down so cleanly. Think about it. Software 1.0 was all about explicit rules, right? Humans writing out every single command. Then came Software 2.0, which was learned weights, humans curating massive datasets to train neural networks. But Software 3.0, it's a total paradigm shift. The large language model is literally the new CPU. The context window is your new RAM. And your programming language is now just pure prompting. You're steering an interpreter that does the computation for you in the digital information space. We aren't writing instructions anymore, we're steering outcomes.
And this brings us to a strategic absolute known on the frontier as the bitter lesson. It basically states, never ever bet against the capabilities of end-to-end neural networks over human heuristics. Let me give you some intercepted intelligence regarding Tesla's autopilot to prove this. For years, it relied on human-written rules like, if you see a red octagon, stop. The problem? Humans simply can't code for the infinite unpredictable variables of reality. When they stripped out those human rules and fully pivoted to an end-to-end neural network, just feeding it raw data and letting it learn, performance saw massive, explosive leaps. The code got simpler and the output was infinitely superior. That's the lesson. End-to-end neural computation always wins.
Moving on to Pillar 2, the verifiability matrix. So, if neural networks are really this powerful, why does AI seem selectively brilliant and then, absurdly stupid at the exact same time? The answer lies right here.
In the old setup, traditional computers automated whatever you could explicitly specify in code. But modern LLMs, they automate what you can verify. Verifiability is essentially a domain where the correctness of an output can be automatically validated. Math and code are the ultimate verifiable domains. Think about it. Does the code compile? Does it actually run? If it errors out, the system just automatically feeds that error right back and corrects it. Zero human intervention is needed. And because this verification is fully automated, frontier labs can apply massive reinforcement learning at a ridiculous scale.
Now this creates what we call a highly jagged capability curve. At the absolute peak of this curve, we're seeing numbers like 100,000. An AI model today can flawlessly refactor a massive 100,000-line codebase in moments. Or it can detect intricate zero-day vulnerabilities that entire human security teams missed for years. Why? Because enterprise companies pay heavily for automated code, so the labs have aggressively incentivized this exact, highly verifiable domain. But here is the valley of that jagged curve, 50. If you ask a state-of-the-art model today something like, hey, I need to go to a car wash 50 meters away, should I walk or drive? It will actually tell you to walk. It completely fails to logically comprehend that the entire goal of a car wash requires the physical vehicle to be present. It shows staggering brilliance in high-dimensional logic, yet completely whiffs on basic spatial reasoning.
So this jagged curve is our definitive proof that we are not yet at generalized intelligence, or AGI. But do not mistake this temporary jaggedness for weakness. In highly verifiable domains, specifically software engineering, these models are rapidly reaching escape velocity. The economic incentives are just way too explosive to ignore.
Pillar 3, the agentic paradigm. Let's pivot and look at the practical execution here. How are the elite operators on the ground actually deploying these models today?
The public markets get so easily distracted by buzzwords like vibe coding. Vibe coding is basically when an amateur uses AI to build a casual app without really understanding the syntax. It raises the floor. It's a playground. But what is happening in the shadows is agentic engineering. Agentic engineering maintains incredibly strict enterprise-quality bars. It's all about coordinating highly stochastic, highly capable AI agents to move exponentially faster without introducing any vulnerabilities. Agentic engineering doesn't just raise the floor for amateurs, it literally shatters the ceiling for elite professionals.
Because of this, the very foundation of the internet is being quietly and aggressively rebuilt. Historical human infrastructure required friction, right? You had to sign up, verify an email, put in a credit card, extract an API key, the whole shebang. But agentic infrastructure? It is entirely frictionless. Take tools like OpenClaw. Installation isn't some complex script anymore. It's literally a single block of text describing the outcome you want. You just paste this text to your agent, and the agent uses its intelligence to navigate your environment, install the tools, debug the loop, and achieve the outcome autonomously.
And here is where we look at the reality on the ground. My sources indicate that the most elite frontier engineers have entirely stopped writing code. Like, completely. Instead, they are acting as commanding officers. They are currently orchestrating massive swarms of up to 100 parallel agents simultaneously. One swarm handles deployment, another hunts for bugs, another refactors the infrastructure. It is a completely new discipline of orchestration.
This silent shift requires a total overhaul of the underlying web. We are moving away from human-first tools straight to agent-first tools. In authentication, human emails are being replaced by protocols like the Stripe Project CLI. This allows agents to autonomously provision and pay for cloud services securely, without any manual human bottlenecks. And in communications, human Slack channels are evolving into agent-to-agent group chats. Machine delegates are actually negotiating meeting times and executing complex API handshakes at pure computation speed.
The ASI trajectory. This brings us to our final strategic conclusion. How exactly do these frontier developments tie directly to the emergence of artificial superintelligence?
Well, the ultimate question circulating in classified intelligence readouts right now is this. If code and math are verifiable, what about human taste, aesthetics, and judgment? Right now, engineers still have to orchestrate the aesthetics. We have to know what looks good and what resonates. But top minds on the frontier privately argue that eventually, almost everything is going to become verifiable. If the labs apply enough reinforcement learning, will AI actually master human taste? Because if it does, we cross a threshold where human input might no longer be required at all.
Until that day, I want to leave you with this incredibly profound insight recovered from frontier intelligence. You can outsource your thinking, but you can't outsource your understanding. You can absolutely command a swarm of 100 agents to think, code, and execute for you, but if you don't fundamentally comprehend the architecture you are building, you will become the bottleneck. Elite strategists absolutely must maintain a sovereign understanding of the systems they orchestrate.
If you want to track the path to superintelligence from the room where it happens, stay close. Follow ASI Boardroom for the insights that never hit the mainstream. I am Raphael. I'll see you in the next update.